It will take a few seconds and it will download both the images and then it will run them. I have been able to connect to Cassandra using the command line. We can just click on the containers and delete all the containers we want to. Hello, everyone. This approach will make your software development process much more easier and simpler. If you are a software engineer, you would have installed a lot of tools. For example, you would have installed Redis, Hadoop, Cassandra, SQL Server, MongoDB, and whatnot. And the problem with installing these many tools is that sometimes you forget uninstalling them. And there might be the case that on odd days of your development, you need Redis because you are working on multiple code bases. And on the event day, you need Mongo. And then you need to have both the services running on your machine, or at times you forget to stop the services. And what you see is a lot of CPU usage and RAM usage. What do you do about that? A great solution to that is you use Docker images. You put everything in an image and you run them. And when you stop the container, then all the processes automatically get stopped. That's it. The only thing you need to do is to create a YML file and run the YML file using Docker command, and all the services will come up. So let's quickly get started. Let's see what is Docker. Docker is a bare minimum OS running as a process on your host OS, which means that, for example, if you have installed Ubuntu or let's say Windows, you can install Docker on top of it. And here, whatever you run, they run as if they are running on a separate VM, but they are not actually a VM. If you see a typical operating system, this is how it looks like. You have hardwares and there is a kernel. For example, there is a Linux kernel, www.kernel.org. It's of 140 MB or so. And then on top of it, there are a lot of operating systems. For example, Ubuntu is one of the operating system. It's of around 4 GB, 3 point something GB. And you can run Docker on top of Linux. And here you can even run Windows images as well. So that's the great thing about Docker, that here, instead of running the complete VM, you run a Docker image, and that Docker image could be of Linux, could be of Windows, anything. And these images can be as small as 5 MB. So this Linux Alpine Linux image, it's just of 7.5 MB. And it will not even take a lot of space in your disk. It will not take much of a compute resource, because if you were installing a VM, it would take a extra kernel space and a lot of UI and stuff. So if you install Ubuntu or any operating systems, you would have seen that it has bunch of games, calculators, UI, a lot of things. But when you are installing things on prod, or when you are doing your development, you are not really concerned about the UI. You are just concerned with the terminal. If you get access to a terminal, you are good to go. So that's what Docker image will be doing. It will give you the bare minimum image. You will not have any of the fancy graphics. You will just have a basic bare minimum stuff, and that will be baked into the Docker image. And this Docker image will still be using the same OS kernel on which it is put into. So overall, a great way, because you have a very small image. You can download the image within seconds. You can start in a few seconds. You can delete very easily. And you can have a lot of restrictions on the image, that what file system and what network stuffs can be accessed by this particular image. So a wonderful way to launch your product in the containerized world. This is our problem statement. Somehow in your team, the project which you are working upon, it's weird. There are two different projects, and both the projects use different set of dependencies. On odd days, the project which you work upon uses Cassandra and uses Apache HTTP server, because that's how it was built. And you clone the repo written in Node, Java, whatever language, and you give the endpoint of these Cassandra and HTTP server, and you do your dev work. But on event days, you need MongoDB and Redis. Again, because that's how it was built. And now it's very hard for you to keep your machine clean. That is, sometimes you work with these, sometimes you work with these, and you need to make sure that they don't clog up all the resources. What do you do about this? What we will do is we'll have a solution with Docker. So this is the solution. We will download and install Docker from docker.com, and then we will make sure that this command docker minus minus version, it's available in the command prompt. It can be Windows, Linux, Mac, whatever option you need to work upon. And then we create two files. One is eventday.yml and the other is oddday.yml. That's it. On event days, we will run eventday.yml with the help of Docker command. And what it will do is that it will download all the dependencies of event days and run it for you. And for odd days, we'll run the Docker command. It will be essentially Docker compose command, and it will download all the dependencies. That is, it will download the Cassandra, it will download Apache HTTP server and run it for you. So it will be all about writing one single YML file, and then you can run them on your machine. And we'll also see Docker Hub. The Docker Hub will be the repository for all the Docker images. So let's quickly move on to the dev machine and set up our YMLs. Let's start with installing Docker. Installing Docker is fairly straightforward. You just have to go to www.docker.com, and from here you need to click on download and you can install it. Once you do that, make sure that if you go to the terminal, you should be able to access the Docker from the command line as well. The same goes for Windows, Mac or Linux, doesn't matter. And when you do that, then there is one more concept that is around Docker Hub. So Docker Hub contains the images or the template for almost all the software development tools. So you just have to go to hub.docker.com and search for the needed image. So for example, if I search for Cassandra, I can find the image for Cassandra, and all I need to do is go here and run this command. And when I run this command, I'll be able to download and run Cassandra on my machine. Likewise, if I search for Mongo, I will be able to find the image of Mongo as well. And again, it gives me the command to download and run Mongo. And these images will be fairly lightweight. So they will be downloaded in your machine. You do the work and then you stop the images. That's it. And you can even delete the images, delete the containers, etc. So let's not get into the details of it and quickly move on to the implementation part. So for implementation, what I'll do is I'll open my IDE. I have moved to my favorite IDE, Visual Studio Code. You can move to your own favorite text editor. And then I created two files. One is eventday.yml and the other is oddday.yml. The syntax is also very simple. You can list the list of services which you want to run on your setup. So I need to run for odd days Cassandra and Apache HTTP server. These names can be anything you want to, but the name of the image has to be the one which is there in the Docker Hub. And these are the ports I have exposed. These things you can find in the documentation, that what are the ports which needs to be exposed. And for Apache HTTP server, I expose the port 80. Once you do that, all you need to do is to have a docker compose -f oddday.yml, and then you need to put up. When you do that, it will download both the images, Apache HTTP server as well as Cassandra, both the images on your machine. And all you need to do is to wait and watch. It will take a few seconds and it will download both the images and then it will run them as well. So let's wait a few seconds and wait for them to run. Looks like the setup has successfully run. It has created a super user role named Cassandra. Now let's move to the terminal. I am currently in the folder in which Cassandra is downloaded. You can even Dockerize this as well, but for the sake of this demo, I have downloaded the Cassandra command line to connect to the Cassandra on Docker because it's just storage in the disk. And here I can run CQL sh. If I do this, you can see I have been able to connect to Cassandra using the command line. And here I can write describe, and you can see I am able to run the commands and get data from the Cassandra cluster using Docker. And I can also connect to the Apache HTTPD server, that is the Apache HTTP server. And if I go to localhost port 80, because that was the port I exposed, it is working. So you can see things are working for me for both Apache server as well as Cassandra server. Now my odd day is done. All I need to do is to do Control C, and both the containers will get stopped. And once they are stopped, I can even see the list of containers. There is no container which is there, and the, the containers in the running state, I can give this, and I can see these are the two containers which are in the stopped stage. And I can even see Docker image, ls images, and I can see two images which are there. So I'm done with the odd day, and let's move on to the event days. In fact, I can delete these two containers and then delete these images as well if I want to. Coming to event days. So for event day, I needed MongoDB. So I created a service called as Mongo. And here I have put the image name as Mongo. The MongoDB documentation asks us to put the username and password using which my services can connect. And I have also put the Redis server. These are the two things I need. Once I do that, all I need to do is to run Docker compose again. So all I need to do is put event day. And now you can see both Redis and Mongo is getting downloaded on my machine. Once they are downloaded, they will start to run. So let's wait for them to be downloaded and then let it run. Looks like both Redis as well as Mongo have started to run. Let's quickly verify it. So for connecting to MongoDB, I have downloaded IDE using Studio 3D, and I have given the username and password. For example, let's click on edit, localhost, root, and the password which was there in the configuration, that was example. And then you can do this test connection. We are able to connect to the MongoDB. You can see all the databases and stuff, and you can run the queries. Let's connect to Redis as well. So first exit from CQL sh, and connecting to Redis is redis-cli. You can download the tools to connect to Redis. It's fairly straightforward, and you can see that we are able to connect to Redis. So we can run command, for example, Anubhav value, whatever, Srivastava, and then I can get Anubhav, and I got the value. So you can see both Redis as well as Mongo are working on my machine. To stop it, I need to press Ctrl C and it will be stopped. And once it's stopped, I can again see Docker container ls -a, all the images. Let me first clear it. And yes, you see two extra images are there. And now none of the containers are actually running on my machine. There is this Docker desktop as well, which I quickly want to talk about. So in Docker desktop, you can see everything using the UI as well. You have containers. These are the images which we downloaded. You can see their sizes and all of them are in the stopped state. What we can do is we can just click on the containers and delete all the containers we want to. So from the UI itself. And likewise, we can delete all the images from here itself and our machine will be cleaned up. No temp folder, nothing. Everything gets cleaned up. We can also go ahead and clear the volumes. So whatever volumes were created, they also can get deleted. This one interesting thing is the dev environment. We can also create dev environment using the feature given in the Docker desktop. However, I would say that it's still in the beta stage. For some reason, when I click on create an environment, it says that Git is not installed. Whereas Git is installed in my machine and it is available using command line. But the same thing works for me in Windows. There is one more thing that it works only with VS Code and it is based on Docker Compose. So even if it doesn't work, we are good to go using Docker Compose. And once this becomes a prod ready, we can try to use that as well. Thanks everyone for watching this video. In this video, we observed and saw that Docker is helpful not just for the DevOps engineer to have the cleaner deployment, but they can be helpful for the developers as well to have a cleaner machine. That's all from my side for this video. Till the next time, bye.